So we have our wave. We don't know what type of wave it is, but it doesn't really matter. Our wave is traveling with a speed of 200 meters per second. The wave number is 1.5 radians per meter. We want to know the wavelength and the frequency. So number one, wave number. What symbol do we use for wave number?
K.
So we know K is 1.5 radians per meter. What equation do we have for K?
2 pi over lambda.
So K is equal to 2 pi over the wavelength lambda. So our lambda, our wavelength, then, solving for it, is 4.2 meters. If you kept an extra decimal place, that's fine.
Like 10.
Nah, it gets a little iffy. We can't be quite that accurate. So we have our wavelength. Now frequency. If we know the speed and the frequency, we can find wavelength. Because we know the speed of a wave is equal to the wavelength times the frequency. So our frequency will be the speed of the wave over our wavelength. So 200 meters per second. Wavelength 4.2 meters. 48. We get 1 over seconds, which is a hertz. So hertz is our units on our frequency. Which is the same thing as oscillations per second or cycles per second. Same thing. By the way, we can also write the speed of our wave in terms of K if we want. Because wavelength would be 2 pi over K. Frequency is omega over 2 pi, omega being the angular frequency. 2 pi's cancel. So we can write the speed of the wave in terms of omega and k as well. And you could have solved right off the bat for omega and then for frequency from there. So keep in mind, this is a really nice equation, really easy to use, but please keep in mind, wavelength and frequency do not affect the speed of the wave. The speed of the wave is determined by the medium itself, what type of wave it is. Questions?